Welcome to our world. Welcome to WorldServe.
Welcome to Drones in Space Exploration. In this module, we'll take you through the incredible journey of how drones have become essential tools in our quest to explore the final frontier. Drones have revolutionized how we explore and understand both our world and beyond. These unmanned aerial vehicles have evolved from simple remote control devices to sophisticated autonomous systems capable of navigating challenging environments. In the context of space exploration, drones offer unprecedented opportunities to explore terrains that would be difficult or dangerous for humans to access directly. They extend our reach into the cosmos, serving as our eyes and instruments in the vast unknown. This presentation explores the fundamentals of drones with a special focus on quadcopters, their applications in space exploration, and the regulatory framework governing their use. What is a drone? A drone is an unmanned aircraft that can fly autonomously or be piloted remotely. It operates without a human pilot on board and can be programmed to perform specific tasks. The term drone encompasses a wide range of unmanned aerial vehicles, UAVs, that vary in size, capability, and design. What unites them is their ability to operate without a pilot physically present in the aircraft, instead being controlled remotely or flying autonomously based on pre-programmed flight plans. It features onboard computers, sensors, GPS, and communication systems that enable navigation and data collection without direct human intervention. From aerial photography to delivery services, agricultural monitoring to search and rescue operations, drones serve diverse purposes across industries, including space exploration. Drones come in many shapes and styles. However, drones can be categorized into 4 types. Fixed-wing drones resemble traditional airplanes with rigid wings that generate lift. They offer longer flight times and greater range, but require runways for takeoff and landing. Single-rotor drones are similar to helicopters with one main rotor and a tail rotor for stability. They provide greater lifting capacity and longer flight times than multi-rotors. Hybrid VTOL or vertical takeoff and landing drones combine features of fixed-wing and multi-rotor designs, capable of vertical takeoff and landing while maintaining efficient forward flight. Multi-rotor drones include quadcopters, hexacopters, and octocopters. They offer excellent maneuverability and hovering capabilities, but shorter flight times. Why are quadcopters the preferred drones? The 4-rotor design provides exceptional stability in flight, making quadcopters ideal for precise maneuvers and hovering in place. Quadcopters offer 6 degrees of freedom: forward, backward, up, down, left, right, and rotation on 3 axes, enabling complex movements and positioning. Their relatively simple mechanical structure makes quadcopters more compact and lightweight than many other drone types, ideal for space missions where weight is critical. Adaptable to various environments and capable of carrying different payloads, quadcopters can be customized for specific mission requirements in space exploration. Thus, quadcopters represent one of the most popular and versatile drone configurations. Their balanced design offers an optimal combination of maneuverability, stability, and payload capacity, making them particularly valuable for space exploration missions where precise control is essential. A quadcopter is more than just a flying machine. Its frame, typically made of lightweight yet durable materials like carbon fiber or reinforced plastic, holds everything together. Motors and propellers generate the thrust needed for flight. The flight controller acts as the brain that processes sensor data and pilot inputs to control motor speeds, maintaining stability, and executing flight maneuvers. Power systems keep it running. Add sensors, cameras, and communication tools, and you've got a versatile flying robot ready for space. For space applications, these components must be specially designed to withstand extreme temperatures, radiation, and vacuum conditions. Quadcopters fly by adjusting the speed of each rotor. Quadcopters achieve flight through the precise control of 4 rotors. By varying the speed of individual motors, the drone can hover, ascend, descend, and move in any direction. For example, increasing the speed of all rotors equally causes the drone to rise, while decreasing them makes it descend. Directional movement is achieved by creating imbalances in rotor speeds. To move forward or pitch control, the rear rotors spin faster than the front ones. For yaw control, diagonal pairs of rotors increase speed while the other pair decreases, creating rotational force without affecting altitude. By mastering pitch, yaw, roll, and thrust, drones can move with incredible accuracy, even in zero-gravity simulations. Drones are already helping us in space. NASA's Ingenuity helicopter flew on Mars in 2021. It has exceeded expectations, completing numerous flights on Mars and providing valuable aerial imagery. The upcoming Dragonfly mission will explore Saturn's moon Titan. New drone missions are being proposed that aim to explore asteroids. These robots go where rovers can't, giving us new eyes on alien worlds. Payload is what a drone carries to complete its mission, like cameras, spectrometers, environmental sensors, sample collection mechanisms, and/or radar or LiDAR systems. In space, every gram matters, so payloads are carefully designed to gather the most data with the least weight. The ground station is the drone's command center. It sends instructions, receives data, and monitors the mission using command and control systems, communication equipment, data processing computers, mission planning software, and telemetry displays. In space exploration, it has to manage long communication delays and limited signals, making planning and precision even more critical. Payload and ground station work hand in hand. While the payload gathers information, the ground station sends commands and processes data. Together, they make sure every mission is a success. In India, the Drone Rules 2021 regulate all drone activity. These rules support innovation while ensuring safety. For space missions, extra permissions from ISRO and other agencies may be needed, especially when testing drones on Earth. To fly drones in India, you usually need to register them, and certified pilots can operate these drones. You'll also need permission depending on where you fly. Green zones are easier, yellow zones need checks, and red zones are restricted. Maximum altitude and line of sight rules keep operations safe and organized. So, do SpaceDryft drones by WorldServe require any special permission? The short answer, no. SpaceDryft drones, part of WorldServe's RoboX series, are educational nano drones designed for learning and recreational use. Nano drones are the drones that weigh under 250 grams. According to Indian drone regulations, nano drones do not require registration or a pilot license when used for non-commercial purposes. SpaceDryft robotic kits serve as a dynamic learning platform for students, hobbyists, and educators to explore key principles of aerospace and robotics. They can be used to understand different disciplines such as experimenting with how weight distribution and payload mechanics affect flight stability. One can learn more about ground station communication, such as telemetry, remote control systems, and real-time data exchange between the drone and control unit. one can also understand concepts of aerodynamics like lift, thrust, drag, and flight dynamics in real-world conditions, enhancing theoretical understanding with practical application. Beyond just flying, SpaceDryft drones unlock a world of educational possibilities across multiple disciplines such as engineering, geography, and environmental science, computer science, physics, and mainly STEM education. With SpaceDryft, the classroom takes flight. However, the following conditions must be strictly observed. Maximum flight altitude must be 50 feet. Drone must remain visible to the operator at all times. Drones cannot be flown near airports, borders, military zones, or protected monuments. As long as these guidelines are followed, no special permission is needed to operate SpaceDryft drones recreationally. SpaceDryft empowers students to engage with cutting-edge drone technology, not just as users, but as creators and innovators. It's more than just flying. It's about building the future of unmanned systems, one flight at a time. Hope this presentation was helpful. Did you know that you can own your very own space drone? Visit worldserve.in/RoboX for more information. We have other varieties of robotics kits available as well. Please do like and subscribe. Thanks for your support.